Okay, there we go. Okay, now my microphone's on. Okay, so I'm going to go over lesson 5.1 notes. The first part, pretty much until page 4, I probably am going to go kind of fast. It's kind of a review on it. So if you have any questions, feel free to ask me when I get back into class, or you can always email me and I can always help you that way. So reviews of quadratic functions. So this first equation, because there's parentheses, there's a square, all those things, that's how I know that this is going to be vertex form. And so a reminder that it has parentheses, and this is really just a way for you to know for certain what it has, but it has parentheses, and remember that the vertex is h comma k. So in this case, the vertex would be -3, 4. The reason it's -3 is because remember this is supposed to be x minus h, but because it says plus 3, it's going to be -3 is going to be your x value. All right. Sorry, I needed a drink. I had to open up my little V8 drink that I drink. Okay, so next we have our x-intercepts, and so the way to solve for your x-intercepts here, if you have vertex form, is to solve. First, we are going to solve for x, and doing that we would have to do not the root, the square root property. Okay. But that's what we would do, is we would solve it for x by doing the square root property. Okay, this next form, it is in standard form. And the way that, that's its form. Okay, the way that we would find the vertex is to do complete the square. Which would give you your vertex form, and then once you have complete the square, you can find your vertex from that point. And so the way to find the x-intercepts on this one is just to solve. It keeps going to my eraser. There we go. So we're just going to solve for x by doing factoring. Okay, so we're going to use the factored method. Okay, so just factor that trinomial, and that's how you will do that there. Okay. And so then we have our next form, which is going to be our factored form. And we know it's factored because it has the parentheses, like 2 sets of parentheses. Okay, but it is your factored form. And so to find your vertex, it actually takes a couple of steps. So the first thing you have to do is just to multiply to standard form, like to get it into standard form. And then we would do complete the square. To find our vertex. Okay, this handwriting is terrible. Okay, and so then the way to find our x-intercepts on this one is just to solve for x. Okay, so what you do is you're going to set parentheses equal to 0. Okay. All right, so looking down here at the equations below, so one thing that they have in common, is that they are all squared. Okay, and then are there any differences? Yes, some are partially factored. And some equal 0. Okay. And we will kind of reference that here in just a little bit whenever we're solving. Okay, so on the back page, so this is going to be the square root property. Pretty much, it's just that if you have an x squared equals a and you're trying to solve for what x is, it's going to be the plus or minus value or the positive or the negative value of the square root of a. Okay, that's what that is, okay? So on example 1, we're solving it for x. So the first thing I'm going to do is I'm going to subtract 4 to both sides. So then I get x squared equals -4. And so to solve, or to get x by itself now, I'm going to take the square root of both sides. And I will have x equals the square root of -4. Now, I can rewrite this as the square root of 4 times the square root of negative 1. And there's a reason for that. There's a reason I would want to do that. The square root of 4 is positive or negative 2. Because remember, negative 2 times negative 2 gives me a positive 4. And positive 2 times positive 2 also gives me a positive 2 times positive 2 gives me a positive 4. Sorry. My brain went blank for a second. And then the square root of negative 1, that is I. Okay, so then this would be your answer there. Okay. So on example 2, we're going to do the same process where we add 45 to both sides. And we get x squared equals 45. So to get rid of that square, I need to take the square root. And I get x equals the positive or negative value of 45. Or you could rewrite it. It's totally up to you. She does put or in the notes. So we could say, okay, that could be the square root of 9 times the square root of 5. And the reason that you might want to do this is because the square root of 9 is equal to 3. So it would be plus or minus the square root, plus or minus 3 times the square root of 5. Whoops, I'm sorry, it would be all of this. Okay. Example 3, same thing. So we get x squared equals 25. And so I'm going to take the square root and I get that x equals, now the square root of 25 is 5. So it's going to be positive or negative 5. And that would be your answer there, okay? So because 25 was a perfect square, I could pull out a whole number of 5 and I won't have a square root at all. Okay, now on example 4, one thing that I actually didn't mention in the video just now, I'm sorry, is that these other ones over here have all equaled 0, right? Well, this one on example 4 doesn't. And so the first thing that we need to do is we actually are going to move that 51 to the other side. So we're going to add 51 to both sides. And we get 2x squared plus 36 equals 0. Oh, wait. Hold on, I lied. We're not going to move the 51 over. We're going to move the 15 over. Let me ignore this. I'm sorry, y'all. So I'm going to add 15 to both sides because we're solving for x. Sorry, I was thinking we were factoring for a minute. So we get 2x squared equals negative 36. So I have to get x by itself. So the first thing I need to do is divide by 2. So I get x squared equals negative 18. And then the last required thing is to take the square root of both sides. So we would have x equals the plus or minus square root of negative 18. Now, she actually does go one step further, because we don't want to take the square root of a negative number. And so remember, we could rewrite that as plus or minus the square root of 18 times square root of negative 1. And remember back from unit 3, the square root of negative 1 is I. So we would say the plus or minus I times the square root of 18. Okay. You could also say, if you simplified this radical, you could also say that x is equal to plus or minus 3i times the square root of 2. Okay, because we could say 18 is square root of 9 times square root of 2. Okay, but this right here is what she has in her notes as her answer. Okay, so that is what I'm going to say is going to be acceptable on your exam. Okay. All right, so on example 5, it says x plus 1 squared. So to get rid of the square, because the difference on this one versus our other ones, on our other ones, it was just the x that was to the second power. On example 5, the entire expression of x plus 1 is to the second power. So we're going to first take our square root of both sides. So I get x plus 1 equals a positive or negative value of 12, because the square root of 144 is equal to 12. Okay, and then I'm going to, actually, before I do that, I'm going to add in a step that she doesn't put in her notes. So now what I'm going to say, I'm going to put x plus 1 equals 12. And then x plus 1 equals negative 12. Because remember right here, it's the it's positive or negative value. Okay, so I'm going to subtract 1 to both sides, and we get x equals 11. And then I'm going to subtract 1 to this side, and I get x equals negative 13. Okay. So both of those answers would be acceptable there, and are correct. Okay, so on this one, everything in the parentheses is being squared, but it's also being multiplied by 5. And so we actually have to get rid of that 5 first. So I'm going to divide both sides by 5. And I get that x minus 3 squared equals 9. Okay, so from here I'm going to do the same thing I just did on my last problem, and I'm going to take the square root. So I get x minus 3 equals plus or minus, what is the square root of 9? 3. So I get x minus 3 equals 3, and x minus 3 equals negative 3. Okay, and so now I'm going to solve it for x. So I add 3 to both sides, and I get x equals 6. And I add 3 to both sides, and I get that x equals 0, which is okay, x can be a 0. That's fine. Okay. All right, now example 7 is a word problem, and I say that because I know a lot of kids don't really like word problems. But it's not bad, okay? So it says if a metal ball is dropped 100 feet from a water tower, its height h in feet above the ground after t seconds is given by this equation. Determine how long it takes to hit the ground. So think about this. As it hits the ground, what is the height? 0, right? The ground is 0 feet. So y equals 0, or you could even say h of x, or actually it would be h of t equals 0. Okay, but what we're going to do is in this equation right here, this equation, where h of t is, I'm going to plug in a 0. So I have 0 equals 100 minus 16t squared. Okay, and so I'm just going to go ahead and solve this for t, which is what we were doing above, on those other questions. So I would subtract 100. And I get negative 100 equals negative 16t squared. Okay, so I'm going to divide by negative 16. Now, I'm not going to reduce that in terms of the numbers because we're going to do something in a minute with it. But a negative divided by a negative is a positive, so I am going to go ahead and put that part. So 100 over 16 equals t squared. So now to get t by itself, I need to take the square root. And so this is the reason I didn't simplify it, is because I can take the square root of 100. The square root of 100 is 10. And the square root of 6 is 4. So it's going to be plus or minus 10 over 4 equals t. And so now I'm going to go ahead and put that as a decimal. And so positive 10 divided by 4 is equal to 2.5. And then negative 10 divided by 4 is negative 2.5. Now, one thing we have to think about is the context of this problem. And so, whoa, those are really small. But so remember, t was equal to time. So if t equals 2.5 or negative 2.5, can you have a negative amount of time? We can't go back in time, right? So we can't have a negative amount of time. So our only answer here is going to be 2.5. Okay, and I'm going to make a note. Okay, time can't be negative. So t must be positive 2.5 seconds. Okay, so time can't be negative. Okay, like I said, we can't go backwards in time. So since it can't be negative, then t must be positive 2.5 seconds. Okay. All right, so now we're going to do our zero property. Okay, and zero property is actually pretty simple, I feel, once you have factored it, so which we've done a lot of factoring. Okay, but I need to factor this equation here, or this trinomial, I guess. So what can be multiplied to give you 36 but added to give you 12? And that's going to be 6 and 6. So the question I kept asking the kids in class is, do we have a leading coefficient of something that's not a 1? And the answer is no. Our leading coefficient here is a 1. So when that happens, our factors are just x plus 6, x plus 6, sorry. Okay, it's just the numbers that are here inside of your x. Okay, so here's where yours, oh wait, we're just factoring right now. I'm sorry, we're just factoring. So here's our factors there, okay? So over here to this next one, again, no leading coefficients of something other than a 1. So I'm going to see what can I multiply to give me 9, but added to give me a negative 6. And that would be negative 3 and negative 3. There's nothing instead in front of h squared, so that's just going to be a 1. Okay, so that means I can just say my factors are not x, because somebody in class was very specific and told me it's supposed to be h. Okay, so I have h minus 3, h minus 3. Okay, so because they're the same factors like the first one was, we would just say, oh wait, I keep thinking I'm factoring, I'm sorry. Or finding the zeros. Not yet, we're just factoring. Sorry, y'all. That's not what I meant to do. Sorry. Okay, and so then now I go over here to number 3 or example 3, and I have, where'd the pen go? Oh, crud, what'd I do? Give me a second. Sorry. Here we go. I want that back up here. Okay, so now I say, okay, what can be multiplied to give me 169, but added to give me 26? And I can take 13 times 13 to give me 13 times 13 gives me 169, and 13 times, or plus 13 gives me 26. So my factors, because I have a leading coefficient of 1, is just x plus 13, x plus 13, okay? I guess it would be g, actually. Okay. All right, so to solve for the zeros of these functions, you would set each factor, which is what's in the parentheses, equal to 0. Okay. So over here on this next example, we do have a leading coefficient of 2. And so remember, when we have a leading coefficient of 2, we have to do slip and slide. So we would say, okay, so what can be multiplied to give me negative 30, but added to give me negative 7? Okay, and we would do negative 10 times 3. And so I know a lot of you prefer the Punnett square, and so I'm just going to show you about the Punnett square. So we have our Punnett square, so our 2x squared minus 15 minus 10x plus 3x, sorry. All right, so 2x squared, I multiplied 2x and not 2, whoops. Sorry, 2x and x. So x times what gives me 3x, and that's a 3. 2x times what gives me negative 10x, and that's negative 5. So my factors are 2x plus 3, x minus 5. But I need to find my zeros. And so this is what I kept trying to do above. But what we're going to do is we're going to take our first factor, so 2x plus 3, and I'm going to put it equal to 0. And then I'm going to take my second factor, x minus 5, and put that equal to 0. So I'm going to subtract 3 to both sides. So I get 2x equals negative 3. And then I'm going to divide by 2. And I get that x equals negative 3 over 2. So that's one of my zeros. And then over here, I'm just going to solve it for x as well. And I get that x equals 5. So those two are our zeros. Okay. All right, so now, because of the solutions we got on the previous example, notice that, like on this one over here, this one, it said x minus 5, but the 0 was x equals 5, so it was a positive 5, right? It was the opposite of the minus 3. So when it says if we know that x equals negative 3, that means that as a factor would be x plus 3 because it's the opposite sign. And then it says x equals 2, so that one has to be x minus 2 because it's the opposite, right? So it says, well, can you determine the quadratic function? And so remember, our quadratic function is a times x minus r, x plus s. Well, here's my x plus s, and here's my x minus r, and it tells me that a is 1. So we could write our quadratic function to be f of x equals 1 times x minus 2 times x plus 3. Okay. You could go through and simplify, multiply it out. She does put a big or here. You could say it was f of x equals x squared minus, plus x, minus 6. You could also say that. All right. Okay, on to page 4, example 8. So again, we're gonna, this one is asking you to use the zero property to solve by factoring. So the first thing that you need to do here is you do need to factor. And so we're gonna multiply. Now, I will tell you, this one is the exact same problem as the first page on the first example on page 3. So you've already done the math. You may just not realize it. Okay, so 6 and 6 will multiply together to give you 36 and add to give you 12. So our factors were x plus 6 times x plus 6. Okay, now we just put one of our, because they're the same factor, we would just say x plus 6 equals 0 and then solve for x. So x equals negative 6, and that would be your answer. Okay. All right, so on example 9, we're going to factor. So what can be multiplied to give you negative 12 and added to give you negative 4? So we're going to have negative 6 and positive 2. So that means that x minus 6 times x plus 2 will give you that trinomial. And so once you've gotten your factors, we're going to say x minus 6 equals 0 and then x plus 2 equals 0. So we'll add 6 to both sides. And we get x equals 6, and then we subtract 2, and we get x equals negative 2. Okay. All right, so on this one, we do have a leading coefficient of something that's not a 1, so we have to do slip and slide. So 3 times negative 3 gives me negative 9. Okay, and we need to add to get positive 8. So I'm going to do 9 times negative 1. So I do have to do the box method on this one or factor by grouping, whichever way you prefer. So we get 3x squared, negative 3, 9x, negative 1x. So 3x times x gives me 3x squared. X times negative 1 will give me negative 1x. 3x times positive 3 gives me 9x, and 3 times negative 1 gives me negative 3. So my factors are 3x minus 1 and x plus 3, But I do need to go ahead and set those equal to 0. So 3x minus 1 equals 0. X plus 3 equals 0. So then I would add 1 to both sides. And we get 3x equals 1 divided by 3. So x equals 1/3. And then I subtract 3 to both sides, and I get that x equals negative 3. Whoa, that was terrible. Negative 3. That wasn't much better either. Okay. All right, if I start going too fast and you're not quite ready for it, slow down, like pause it, okay, and come back to it. Of course, you can always ask your peers tomorrow for some assistance as well. All right. All right, so on number 11, we don't have the x and the 3x together, so I need to move the 3x to the other side. So when I do that, I get x squared minus 3x equals 0. Now, this one doesn't look like the others because it doesn't have 3 terms, okay? But what we are going to do is we're going to see that x squared and negative 3x have an x in common. So that's going to be x minus 3 when I pull out an x. And so now you do have it factored, even though it doesn't look the same as normal. Excuse me. So what you'll do is you just pull this one out and you say x equals 0. Set it equal to 0, right? And then we say x minus 3 equals 0. Well, I don't have to do anything to solve this one. X is already by itself. So that's one of my answers. And then I add 3 to both sides, and so now I get x equals 3. And so that's my other answer. Okay. So we're going to do the same thing on this one. Okay, there's not a trinomial, but they do have an x in common. So we get x times 3x minus 7. So again, this equals x, or x equals 0 there. That's solved. And then I need to do 3x minus 7 equals 0. So plus 7 on both sides. So 3x equals 7. We divide by 3. X equals 7/3. Don't worry about simplifying this, okay? Leave it as 7 over 3. I know kids tend to hate fractions, but let the fraction be your friend here where you don't have to simplify it, because that's going to be an ugly repeating decimal, okay? All right, so on this next one, because there is the 7 over here, I need to go ahead and distribute this x. If this 7 was a 0, I would solve it like I've been doing, but it's not. So I need to first distribute. So x times x gives me x squared. And then x times negative 6 gives me negative 6x equals 7. So now I'm going to go ahead and move that 7 to both sides. So x squared minus 6x minus 7 equals 0. And then I'll factor. So we get negative 7 and negative 6. Okay, so negative 7 times positive 1 gives me negative 6. So my factors are x minus 7. X plus 1. And so then I'll set it equal to 0. X minus 7 equals 0. X plus 1 equals 0. So I add 7 to both sides. So x equals 7. So x equals negative 1. Okay. All right, so going on to completing the square, I will tell you there's only 3 pages of notes because we are not going to do page 6. It's kind of unnecessary. It's just to, I don't know. It's just to let you drown in your tears, I guess, because it's a lot of work. In fact, I'll show you. I will go ahead here in a little bit when we get to it. I'll pull it up on the answer keys. That way, those of you that just want to attempt a very challenging thing, you can see what they do, but it's a big mess for nothing, if I'm being honest. But anyway, so when completing a square, okay, what form of the quadratic did we generate? So remember, we generated vertex form when you did completing the square. So if a quadratic is in vertex form, then any equations involving that function can be solved by using inverse operations in the square root. Okay. So the big idea with this method is that every quadratic has a vertex. So remember, vertex, so if I have a quadratic here, the vertex is the little point where it can be cut in half and folded on itself. And so that means that every quadratic can then be written in vertex form. Okay. So completing the square is a method for solving that will work on every quadratic equation. Okay. So what we're going to do here is we're going to practice some more with completing the square. And then from there, we will then find our zeros. Okay. So there's nothing that can be multiplied to give me negative 6, but added to give me negative 4. Okay, but also remember, we're trying to do completing the square. So that's when I say, okay, x squared minus 4x plus something, minus that something, and then minus 6. Okay, so remember, this is when we do negative b divided by 2 squared. Okay, or the opposite of b. So in this case, the b is negative 4. So the opposite of negative 4 is 4. 4 divided by 2 is 2, and then 2 squared gives you 4. So our somethings here is going to be 4. Now, one thing I don't know if you have picked up on, so let me write it out over here. So negative b, where the opposite of b is 4. Oh, it's not opposite of b. It's just b squared. I'm sorry. B divided by 2. Sorry. B divided by 2. And we square it. Well, negative 4 divided by 2 is negative 2 squared. This is what you're going to use as your factor. So we would have x minus 2 squared. I don't know if you picked up on that. Okay, but whenever you do b divided by 2, that is now your factor. Okay, so we have x minus 2 squared, and then negative 4 minus 6 gives you negative 10. Okay, so once you have done completing the square to get it to vertex form, you are then going to set it equal to 0 and solve for x. So we're going to add 10 to both sides, and we get x minus 2 squared equals 10. Square root of both sides, we get x minus 2 equals the plus or minus square root of 10. And then we add 2 to both sides. So that means that x equals 2 plus or minus square root of 10. Now, she does go on, just so you know, and lists out her answers as x equals 2 plus square root of 10 and x equals 2 minus square root of 10. Okay, and this is her answer. Okay, she doesn't put the one where it's 2 plus or minus 10, square root of 10. Okay. All right, so over here on the next one, so the first thing we need to do is we need to get the 2 to the other side because that has to be on the same side. So we subtract 2 to both sides. So 3x squared minus 6x minus 2 equals 0. Now, I can't have that leading coefficient there. Okay, so I'm just going to divide by 3 all the way across. So I get x squared minus 6, minus 2x, excuse me. And then minus 2/3, okay? But then I'm going to do completing the square. So I'm going to say, okay, x squared minus 2x plus something minus something minus 2/3. So remember, we do b divided by 2. So negative 2 divided by 2 is negative 1. And negative 1 squared gives me 1. So we just have a 1 right there. Okay, and so then from here, that's just going to be x minus 1 times x minus, x minus 1 squared. And then negative 1 minus 2/3 is negative 5/3. Okay, and we're going to put that equal to 0. So I'm going to add 5/3 to both sides. X minus 1 squared equals 5/3. So I got to take the square root of both sides. So I get x minus 1 equals plus or minus the square root of 5/3. And then I add 1 at the end. So I get x equals 1 plus square root of 5/3. And x equals 1 minus the square root of 5/3. That's my answer. Okay. All right, and so then down here on example 16, so I need to go ahead and divide by 2 because I have a leading coefficient. So I get x squared plus 6x minus 5. And since I'm doing completing the square, I'm going to say x squared plus 6x plus something minus 5. Now, half of 6 is 3, and 3 squared is 9, so my something is going to be 9. So because half of 6 was 3, that means that I would do x plus 3 squared. And negative 9 minus 5 is negative 14. Once we have it in vertex form, I'm going to put it equal to 0. So I have plus 14 on both sides. So we get x plus 3 squared equals 14. So I take the square root of both sides, and I get x plus 3 equals plus or minus the square root of 14. So we get minus 3 on both sides. So we get x equals negative 3 plus the square root of 14. And x equals negative 3 minus the square root of 14. That's it. Okay. All right, so as promised, let me show you really fast. Okay, if you were curious about page 6, because I'm not going to jack with it. Here is page 6. Let me turn my screen. Okay, so take a screenshot of that. If you're curious about it, what she's wanting you to see here is how the quadratic formula was derived. There's a lot of what am I trying to say? Variables and just all the things when you solve that. And listen, it's not necessary for you to know where it was derived from. But if you're curious, go ahead and just solve it out, okay? Go back to that part in the video where it was at and just go ahead and start plugging your heart away. Get after it, okay? But one thing to know, and you may or may not have seen the quadratic function before, but the quadratic function, and I'm going to write it at the top of our screen here, or the top of our page, excuse me. And I will tell you that I will also give this to you on your test, your Unit 5 test, your midterm, anywhere you need it. I will give you the formula, okay? But the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I will tell you, that sounds like a lot. Like you're probably thinking, oh my gosh, that is literally 3 letters. Like how in tarnation am I supposed to do this, right? Well, don't worry. I got your back, as I do, okay? I'm going to show you what you need to know. Okay, so remember in a quadratic function, the number in front of your x squared is your a, so this is a, this is b, and this is c. Okay, and so those are the numbers that we're going to plug in. Now, I am going to go ahead real quick and write the quadratic function again because I zoomed in and you can't see it. It's up to you if you rewrite this, though, because you should have this at the top of your page. Okay, and so what we're going to do here is we're going to plug in these numbers. Okay, so negative b, so b was 11, so we would have negative 11 plus or minus square root of b squared, so 11 squared, minus 4 times a, which is 1, times c, which is 20, and all of it is over 2 times 1, okay? Now, we are going to simplify this. You can do it in your calculator, but I will tell you your calculator is going to give you a decimal form, and our instructor is not going to, I don't think that they will accept the decimal form. So you will need to do some of the math yourself, okay? So we have negative 11, and I'm going to walk through the math that I expect you to be able to do. So we have negative 11 plus or minus the square root. 11 squared is 121. And I'm going to highlight this for y'all so y'all know where this is coming from. Okay. Minus 4 times 1 is 4 times 20 is 80. Let me do a different color here. So this 80 came from multiplying all this together. All over 2 times 1, which is 2. Okay. Now I can solve it or simplify it a little bit easier. Okay. Or a little bit more, I should say, excuse me. So I would say negative 11 plus or minus the square root. 121 minus 80 is 41. All over 2. And she will accept this answer, or she'll accept negative 11 plus the square root of 41 over 2, okay, comma, like another answer, because we're splitting up the negative and the minus, or the negative and the positive. So negative 11 minus the square root of 41 over 2, okay? So either one of those answers are correct. So again, the formula probably looked a little scary and ugly and nasty, but take it one step at a time. I will tell you too, I've discovered in math, if you take things one step at a time, it winds up not being that bad, okay? All right, so again, A, B, and C, okay? So our formula says negative B, so negative, but B's negative 114. Plus or minus the square root of b squared minus 4 times A, which is 1, and C, which is 9, all over 2 times 1. So negative times negative 14 is a positive 14. So positive 14 plus or minus negative 14 squared is 196. Okay, I'll go ahead and highlight again for y'all. Oops, that's green. So this comes from this. Minus 4 times 1 is 4, times 9 is 36. So that 36 came from multiplying all three of those together. Okay, all over 2 times 1, which is 2. Okay. All right, and so now I need to do my subtraction inside, so I get 14 plus or minus the square root. 196 minus 36 is 160, all over 2. Okay, and the last thing, actually, she does several ors here. So she will take this answer, or 14 plus square root of 160 over 2. And 14 minus square root of 160 over 2. Or 14 divided by 2 gives me 7. So 7 plus or minus the square root of 160. Okay, all of that is, whoa, I don't need to undo that. All of that. Okay. Is an acceptable answer and appropriate. Okay. All right. So now we, again, are on number 19. Okay. 3 is our A. Negative 2 is B. And 11 is C. So I have negative 2 plus or minus the square root of B squared. So negative 2 squared minus 4 times A times C, all over 2 times A. Now negative times 2, a negative 2 is a positive 2, plus or minus. Negative 2 squared is 4, minus 4 times 3 is 12, and 12 times 11 is 132, all over 2 times 3, which is 6. Okay, so we're going to simplify this, and so we would have 2 plus or minus 4 minus 132 is the square root of negative 128, all over 6. So that's an acceptable answer. Or I'm not even going to try to, let me think. I can pull that negative out, so I could say, okay, hold on. I'm going to have to do a couple of steps. So remember this. Let's just remember this. This is an answer. Okay, because these other ones you're going to be like, what the heck? How'd you do all that? Okay. All right. Example 20, last one on this page. Now, the negative 2 is not on the same side as the other stuff. Okay. So we need to move it over. So we're going to add 2 to both sides. And we get 3x squared plus 18x plus 2. So 3 is your A, 18 is your B, and 2 is your C. So negative B, so negative 18, plus or minus the square root of 18 squared plus, B squared minus 4 times A times C, all over 2 times A. So we get negative 18 plus or minus the square root. 18 squared is 324. 4 times 3 is 12, times 2 is 24, so minus 24. All over 2 times 3, which is 6. Okay, so then I have negative 18 plus or minus 324 minus 24 is square root of 300. All over 6. This is an answer, and so we're going to leave that. Okay. All right. So that is kind of covering the notes, or is covering the notes, not kind of. Now, I will tell you, I know that there are 8 problems on the back of the notes. And so what I'm going to do is actually assign those as your homework in place of Unit 5, Section 1 homework, high school homework. So you will need to finish examples 21 through 28 by, let's see, today's what, Tuesday? You need to finish that by Thursday, end of day. You will not have time in class to do it unless you finish this video early tomorrow during our class, and then you're able to finish it. But I will not give you a specific time in class to do those examples. So make sure that you're doing them, okay? So again, to recap that, section 5.1, unit 5, section 1, page 8, which is examples 21 through 28, that will be assigned as high school homework. And it is due on Thursday by end of day. So when I say end of day, you have me second period. If you need to work on it during lunch and get it to me before the end of the day, that's fine. But just remember, I'm not in my class 8th period or 9th period, okay? And so make sure that you get that turned in when you are able, okay? All right, if you have any questions, feel free to let me know. Have a good one.